So if you go ahead and open up the file called tangent, you should have this here. So let's talk through what we've got here. We're interested in a circle, and what we want to do is we want to look at a point on a circle as that point just rotates all the way around. So we're interested in this little red point here, so you can forget about the rest of the lines for the moment and just focus on that little point there. Now you can come up here and you can grab this little circle here, and if you drag it along, you'll see that the little red point just rotates anti-clockwise round about the circle. So this is the point here now. So we can go all the way around the circle until that point goes back to the beginning again. We can also work through backwards, and you can see it heading back towards the beginning. And of course you can press the little play button and you'll see it working its way all the way round about the circle, and then it just keeps working back and forwards. So everything that we want to know about the trigonometric functions, the sine, the cosine and the tangent, we can work it out from this little diagram. So the first thing we're going to do is look at the tan function. Now, whenever we talked about functions before, we know that a function is something that relates one quantity to another quantity. So we are interested in relating this y-axis here to an x-axis. But what goes up the y-axis and what's along the x-axis? Well, along the x-axis we're interested in the angle, so that's this little angle here. So really what we're thinking about doing here is we're going to take all these angles from 0 all the way around to 360, but we're going to put the angles along this axis. So if you like, you can think about opening the circle up so that we've got access to all of the little angles, and all the angles go along this x-axis. So the angles will go from 0 all the way along to 360. And what's going to be in the y-axis? Well, the y-axis is our function, which is the tangent. So the tangent is going to be given by the ratio of the y length, so that's this length here, divided by the x length, and that's this length here. So it's probably best seen by just putting the function in. So we're going to get access to the function now. So I'll click on this, and I can click on the very first one up here, and it's going to show us what the tan function looks like. So let's put this back to 0. Now as we move up along the circle, so we head in the anti-clockwise direction, you'll see this little black dotted line. Well, this is our function, and this is our tangent function. So let's just draw it in so you can have a look and see what it looks like. Now, of all the trig functions, the tangent is probably the most complicated looking. So you can see here, this is our tangent function, and it's the dotted line here. So let's talk through and we'll see how we're able to create this dotted function. So we're going to start off with our circle here, and we'll put everything back to 0. So this is back there at the 0 point. Now what we're interested in with the tangent is the ratio of the y distance divided by the x distance, and that's all we're interested in all the way around this circle. So if I move it further round, we're interested in this y distance divided by this x distance. So at this particular point you can see here that we've got some y value here and we've got an x value here. Whenever we divide them out, we're going to get the value of the tangent. Now I've actually written this in here, so when we divide this length by this length here, we get a value of 1.964. So what we do is we come along the angle, so this is the angle here. So we're going to come along this angle, and then we're going to plot up the point 1.964. So this is the angle here. So at this point here represents this angle here. And then to get the height, we're plotting off the ratio of this length divided by that length, and that gives you the value of 1.964. So we just come along there and we go up to 1.964. Now you might be looking at this and saying, but wait a minute, along this axis I thought you said the angle is going to be from 0 all the way along to 360. But whenever I've drawn this out, I've only got this value here. It's going from, looks like from 0 up to about 4 or 5. Well, what I've done is I've changed the scale along this axis, because if I was to make the scale of this axis actually from 0 to 360, then what would happen is that in order to show the function out properly, it would mean that you wouldn't be able to see any of this, and the function would be spread along the 360 degrees here. So I've changed the scale in this axis just so it makes it a bit easier for us to see what the function looks like. So this allows us to see the circle and the triangle and all the angles and the function here as well. So the scale along this axis is in something called radians, but we'll get on to that in a later video. We don't need to bother about that for the moment. So let's just follow this round about and see if we can work out the logic of how what this function looks like. So we're interested in the ratio of this y distance divided by the x distance. Now we can see that as this little red dot tends towards the value of 1, we're going to have this length here is going to get bigger and this length here is going to get smaller, and you can see that happening here. So eventually what happens, whenever this little point here sits on the value of 1, the y height is going to be a length of 1 and the x distance is going to be a length of 0. So you're going to have the ratio of 1 divided by 0. 1 divided by 0 is infinite. So it means that this line here is going to tend off towards infinity. So we'll see that happening here. Okay, so you can see here it's actually heading up to a large value, but because of the scales on this, it's difficult to get. But you can see that's at a value of 14.14. Now as this angle here tends towards the 90 degrees, then this height here tends towards 1, the distance here tends towards 0, we have 1 upon 0 which will be infinite. And you can kind of see that here. You can see that the tan function is going to head off towards infinity. So let's continue round the circle. Now what's going to happen, whenever this little dot goes just beyond the value of 1, then we're going to get the height here is going to start decreasing again, but the length distance here along the x-axis is going to start increasing, but it's going to become a negative value. So you can see this happening here. So if we go down to this point, say here, you can see that the value of our y distance or height is starting to get smaller again. The x distance is increasing, but the x is becoming a negative value. So you're going to have this y divided by x is going to be a positive divided by a minus will give you a negative value, and that's a minus 1.7 here. And you can see here as we continue working along, you'll see the function actually appearing here in the bottom right. So what's happening here is that as we go to this angle here, so this is the angle along here, so this point here 2.5 represents the angle here from here all the way round to this point here, and the height here is going to be the value of minus 0.747, which is just this distance here divided by this distance here. And we continue along here until eventually we get this x distance here will tend towards a value of 1 and the y distance will tend towards a value of 0. So we're going to have the value of 0 upon 1, which will just give you a value of 0. So when we get along here, this just tends to the point 0. And you can see the tan there, you see it tending off towards 0. Now I'll zoom out a bit so you can see the rest of it. Now if we head into the third quadrant, so this is the first quadrant, that's the second quadrant, and this is the third quadrant, you can see now that the y distance is getting bigger and the x distance is getting smaller, but both of them are negative values. The y value is negative, the x value is negative, so when you divide a negative by a negative, you get a positive value, so the function starts to head up again. And again, at this value here, which is round 270 degrees, the tangent of the function tends off towards infinity again, and again it heads back up again from the minus infinity back up towards the value of 0. So this is a full tangent function, and you can see that the tan function actually repeats every 180 degrees. So this point here is a distance of 180 degrees, and along to this point here is a distance of 360 degrees. So this whole function starts repeating every 180 degrees. So the best way to get an understanding of this is to open up the graphical calculator and have a little play with this yourself. And it's quite straightforward, it's quite simple once you take your time to grasp what's happening with this little dot as it goes round the circle, and what's happening with the y coordinate, and what's happening with the x coordinate as the dot goes round the circle. So let's move on and we'll look at the sine function next.